Hello everyone, welcome to Conf42 Observability 2025. I am Venkata Madhu Prateek Reddy Kambala, a senior DevOps engineer with 15 plus years of experience in IT. I started working as a network engineer in both enterprise and data center domains, and then moved to cloud as a DevOps engineer, and now working as a senior DevOps engineer implementing DevOps and DevSecOps methodologies for deploying infrastructure into AWS using services like compute, storage, databases, serverless infrastructure, and as well as containerized application infrastructure. And I also have experience across domains like mortgage, finance, healthcare, insurance, and e-commerce. The topic I chose today is logging in the age of cost cutting, smart strategies to reduce bills. Over the last decade, companies migrated a lot of their workloads to cloud because of ease of use, high availability, fault tolerance, and scalability. And also, cloud provided exponentially fast path for moving from ideation to like implementation compared to traditional data centers. So all this, movement to cloud, like there is a lot of cost incurred. So the latest buzzword is FinOps, where cost optimization is like kind of a topmost strategy, and logging is one such aspects where cost optimization is looked at. So today we will dive into how like industry leaders like Uber, Airbnb, and Slack implemented like their cost optimization strategies, reducing 70% of their bills while retaining the same level of debugging capabilities and as well as monitoring capabilities. So let's dive into that. So let's see what causes all this cost crisis for logging. As per the research available openly, Airbnb kind of spent like 1.2 millions a year for stale unused debug data. So there is a research that states that like for all the logging that is generated, only 30% is used for all the queries and like monitoring and any meaningful operations like that an enterprise can do. And rest of the 70% is sitting there in the storage, costing enterprises like a premium without any use. So this problem even compounds with microservice architecture because each microservice generates its own logs. So yeah, we will look into how Airbnb mitigated and how like we will also look into other companies on different strategies of cost optimization for logging. But yeah, this is what causes costing for logging a lot. So let's go into the next slide. So here we will look at why the costs are spiraling out of control for logging. So mainly the first one would be microservice explosion. So we moved from monolith architecture to microservices architecture, which created a lot of services, and those services like independently generate a lot of log streams. So creating all those log streams and maintaining them paved for exponential log generation, log creation, and log storage, which added to all exponential costs. And then cloud vendors have a pricing at both ingestion and storage level. So you're kind of getting double charged. Like so you'll be charged for per GB while you're ingesting the data, and as well as while you're storing that data for later retrieval purpose. And then there are some development practices where some applications or some enterprises like users or developers still have debug level logs enabled in production, which is not recommended because debug generates a lot of log data, which is not used most of the times, unless there is an alert or there is something that needs to be troubleshoot. Enabling debug log level is not advised because that increases the sheer volume of logs it generates, and 90% of the time or 99% of the time it is not needed. And then there is lack of governance, right? Like where there are no clear policies on how log collection should work and what are the optimization strategies, and inconsistencies cause to excessive logging, and excessive logging causes to excessive storage, so it incurs again cost at both levels, like for ingestion and storage. So we will look into the first strategy, which is implementation sampling. So Uber had a big breakthrough. Like Uber, we mentioned, 70% of the logs generated are unused. With respect to debug, it's almost like 95% that is unused. So what Uber did was like it implemented a sampling mechanism, and using that sampling mechanism, it was only retaining 5% of the debug logs that is generated, discarding 95% of 95% of them, which helped them save around $8 million annually. And this was published in SRE Con 2022. So yeah, while they were doing that, they still retained the error logs. Like they were only sampling debug logs, so they were reducing the noise while keeping the effective logs that are needed for maintenance of the infrastructure. So there are three different kinds of implementation approaches for this: head-based sampling, so where the decision is made at the log generation as itself. So like source, right? Like wherever like the microservices or infrastructure components are used, at that place itself, there is a sampling mechanism used where it drops 95% of the debug data. Whereas there is another approach to it, like tail-based sampling mechanism, where the decision is made after the trace is completed and ingested in like at the ingestion process. So Uber implemented this and saved saved 8 million in cost, for logging. And then there is level-based sampling mechanism where like it can use like at a different rates at different log levels, which is also one of the widely used approaches. For best practices, like we should always preserve error and fatal log levels. That is what helps us for effective troubleshooting and keeping track of what services went down and alerting and other stuff and all. So we should never be sampling error and fatal logs. And you can start sampling can be done from 1 to 10% for debugs and info level of logs, but like you can always start at 10% and then build your way up to 1%. And also we have to use consistent sampling methodologies and also service boundaries for effective sampling. Here we look into a second strategy, which is called noise filtering. Like we said, 70 like out of 100% of the logs, 70% is just noise that is generated that is never used. So Slack encountered similar kind of situation where there were health check logs that were not meaningful to them, but they're still kept on accumulated by the logging and methods they had, which incurred both ingestion cost and as well as storage cost. So Slack implemented a fluent bit filtering mechanism where they dropped all the health check data that was not necessary, which dramatically reduced their cost by 15% with zero impact in their day-to-day operations. So generally the common noise sources would be health check endpoints like ping, health, or status endpoints. And then there are repeated connection timeouts that are not critical. And also we don't need to maintain all the successful authentication logs. And there are some service to service communications between the services that you can drop and not retain. So filtering is one of the most effective mechanisms because you can just drop the logs that you don't need, effectively helping in cost optimization. And also it's effective when you're able to identify systematic noise sources that you can kind of filter out at ingestion layer itself. So you're not ingesting them as well as storing them, saving a lot of the cost there. There is another strategy that we can use. Like this is like the earlier two, we were looking at kind of generation log generation level and ingestion level. This comes at storage level. So there is a storage strategy, the 3-tier storage strategy that you can implement. So it can be classified into hot storage, warm storage, and cold storage. So hot storage is something for a week of logs, right? So anything from today to last 7 days can be a hot storage stored in Elasticsearch, which helps to query, which helps for a better query rates and retrieval rates. And for anything between 7 to 30 days is less queried compared to the ones that are queried in hot storage. So we store them under a warm storage using standard S3 buckets, which has balanced cost and performance ratio. After 30 days, most of the applications are an enterprises won't need to have logging data that is readily queryable every for day-to-day use. So we can move that to glacier storage where the cost would be very less for retaining, but you should be careful while doing that because querying glacier data is really tough because of less retrieval speeds for data. So, but Shopify implemented one of these, this approach, and they were able to save 60% in their retention costs. And they were like generally like they needed like anything logs for like beyond 30 days for compliance. So that is the reason they are retaining it. But yeah, this reduced around dramatically their retention cost like for logging. And there is a fourth strategy which kind of shifts your logging cost to like a personal cost. So in a way, Razorpay, one of India's major payment gateway, was able to opt for an open source solution like Grafana Loki instead of Splunk, and thereby they saved around 200K dollars. So like Splunk was costing them $250,000, whereas Grafana and Loki implementation just like costed them $50,000 because of how like Loki's architecture is cost effective while using S3 for storage. But this comes at a cost from operations perspective, where you will have to have like a subject matter experts implementing the solutions to maintain the infrastructure for open source, where you will not have application support or vendor support. So that is the cost that you'll be incurring, but definitely reducing your logging cost. So we will look at like a real world case study that Uber implemented. So Uber had a challenge where there are 250,000 Spark jobs that run daily, generated around 200 TB data. So that storing that data is very costly. So they came up with a compressor CLP, which is called compressor log process, where they achieved a compression of 169 is to 1 ratio, thereby reducing their costs from 1.8 million to 10K annually. So that is 99% reduction in cost. So they implemented a compression mechanism of compressing logs, and were able to achieve this remarkable feat of reducing their cost. So, and while this also helped, this compressed log processor solution also helped them query the logs without decompressing them. So there was no deterioration in their querying and monitoring needs. So another best practices for logging is structured logging. So if you see the example here on the left side, it is an unstructured logging where an user is trying to create or sign up for a new account, but using an email address that is already signed up for that particular service. On the right side, you see the same thing for a structured log using a JSON, which contains all the metadata and timing information. So the right side structured data helps us to query better. The more we have structured logs, the better for us from operations perspective, and as well as storage perspective, because it helps in compression. So we can look at at the bottom we see all the things that structured logging data can provide. So it enables precise filtering, because you can target based on the metadata, you can select a few fields and target filtering based on that. And also it improves better compression mechanism of just how structurally it organized. And then it enhances your query performance as well. Apart from your regular queries, you can use JQ and other queries as well, and there is more metadata and more fields that you can query on and retrieve the data in an efficient way, and also which also paves ways for better automation. So for optimization success, you'll have to have financial metrics, operational metrics, and volume metrics optimized properly. Whereas financial metrics will have your monthly ingestion costs, storage cost per tier, and also total GB ingested, because as we discussed earlier, clouds charge at GB ingestion level as well, and also at the storage level. Coming to operations, you have to see how far, so when we are implementing all these strategies, you'll have to always make sure how fast your query response is, because that is what matters at the time of troubleshooting, or looking into services on what is happening there, if something went wrong there. And then and you'll have to also make sure that log is available, and with all the sampling mechanism you're doing, how effectively you are able to detect the errors. and then the volume metrics, like, so you have to look at like daily volume trends, and as well as like how much is filtered versus retained, and from all this, like how much like storage cost like you're incurring. So the key is actually establishing baselines before implementing the changes and then tracking improvements over the time. So with all this, like I mean, strategies like noise, like I mean, filtering and sampling and everything, like there are some common pitfalls, and we have to be like I mean, let's look at like I mean how we can avoid them. So anything like I mean that is aggressive or like I mean overdoing will cause an issue. So like I mean over and aggressive filtering will always have some repercussions. So you might be losing some critical debug information. So always while doing sampling and filtering, like I mean always start conservatively, then increase like gradually based on like I mean what you're seeing. And always like I mean make sure that you preserve error and like fatal level logs. You are not filtering them out, or like I mean you're not sampling them. Make sure you retain them completely. And then while sampling, you'll have like I mean sampling bias, because like just because of how your sampling mechanism is implemented, like you might miss some of the infrequent like events that come up in your logs. The solution would be like I mean using some trace aware sampling mechanisms, and also you can like implement a safeguard like by triggering like I mean full triggering like I mean stopping of sampling by using an alert. So if you see a alert, like then stop sampling, like you can like implement certain triggers and do that. And then like I mean cold storage query performance. So retrieving data from cold storage is really painful. So you can't like I mean write a query it's not easy to write like I mean querying mechanism to pull data or retrieve data from cold storage. So design like I mean your queries in such a way that you are not accessing cold storage. Like I mean for your queries, mostly you're using hot and like your warm storages. Also, like I mean, you can implement some of the rehydration workflows of moving like I mean the cold storage data into warm or standby for better like I mean querying like I mean speeds. So now we will look at like a cost optimization roadmap. From looking at all these strategies, like I mean, what can be done for this to be implemented in your organization? So first, you'll have to assess and analyze. So you'll have to look at immediately you can look at your log volume and audit like how much volume you're seeing, and then isolate like I mean 5 to 10 log streams that are like or log sources that are causing like really high volume of logs, and then calculate like how much you're spending on those logs, and set up like I mean dashboards. See like I mean what are your quick wins, and implement some kind of like the strategies like we discussed earlier, either filtering or like I mean sampling, etc. And like after like while you monitor that like I mean and get to a conclusion, after 30 days you can start implementing like we discussed, right? Like you can start implementing health check filtering, log sampling, and then like for storage needs you can do three-tiered storage. And also we looked at like I mean certain open source logs. And in long run, like, and you can always have like some strategic initiatives like we discussed, open source alternatives, and advanced compression techniques like Uber did with CLP. And you can always have like a log-based metric alerting, and you can bring most training for cost optimization and culture around that in your enterprise. So that concludes like how we can save in logging. So there are other essential tools you can look at. For example, Datadog management, cost management site, and as well as like all the open source applications like Grafana, ELK, etc. And there is CLP open source if you want to implement it. At the same time, like vendor specific stuff you can see in Datadog, and Uber also maintains a good treasure trove of like a CLP technical papers, which is a blog, and that has all the technical papers where you can read through on how they implemented that successfully. And the same way, cloud service providers also have best practices of white papers like AWS and GCP. And then there are always conferences like SRE and Lisa, like conferences, and even our Conf42, like we are doing as of today, where they kind of like talk about these situations and make us aware. And then there are like cloud native foundations, communities or your internal communities that you can discuss and get like better approaches. That's it for today, and thank you.